If I had to describe this video, I would name it Sequences of Transformations Level Up. Level up as in we're playing a game. And I want you to see this as a game. This game has 3 rounds, and your goal is to make it to the third round and complete the third round alone successfully. On the first round, I will do the first problem for you and walk you through the second problem. In the second round, I will do the first problem with you, and you're on your own for the second. And in the third round, I'll leave you to do the problems, both of them on your own. The goal is to be able to complete the third round without me. Now, if you do not complete the third round without me, but you are able to complete the third round with me, consider yourself proficient. If we have finished the third round and you are still lost, let me know so that we can do more work with sequences of transformations. The outcome for this production is I can describe a sequence of transformations that will prove congruency or similarity among triangles. And you will need more graph paper and perhaps patty paper to complete these transformations with me. Go ahead and get a sheet of graph paper and have your pencil ready, and let's get started. Okay, here is the first exercise, and this is level 1. The directions are, the direction is to describe the sequence of transformations that will map ABC onto A double prime, B double prime, C double prime. And we're going to walk through this one together. First of all, I want you to notice that the first triangle is ABC. So this is the original triangle. The second triangle is A prime, B prime, C prime. Study what happens from the first triangle to the second triangle. Do you see it? What happens? You should have said that it is a reflection across the x-axis. Here's the x-axis. Excuse my crooked lines. But here's the x-axis, and the triangle is being reflected across the x-axis. That reflection goes from here to here. Now, once it is reflected across the x-axis, we then have to look at what happens when we move from the second triangle to the third triangle. Now, obviously, it is not a reflection. It could be a rotation, but the size changed. And because the size changed, we can't say that it is a rigid motion. So we can't resort to translation, rotation, reflection. The only one that's left that impacts the size of the figure is dilation. So now the question is, what happens in this dilation? Well, take a minute and think about it. What happened in this dilation? Remember that scale factor is equal to the dilated figure over the original. So scale factor equals dilated over the original. And you have to excuse me because I don't have my slate so that I can type this while I'm speaking. But this is dilation over the original. So, knowing that scale factor is equal to the dilation over the original, the first transformation we concluded was a reflection across the x-axis. So I'm going to write that the first transformation is a reflection across the x-axis. Then there is a dilation with a scale factor of dun, 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 dun. What is the scale factor? Hopefully you said that the scale factor is a fraction because it got smaller. It went from being 1, 2, 3, 4 to being 2. So it went from being 4 to 2. It got smaller. In order for something to get smaller, when something gets smaller, it becomes a fraction of what it is. So right here, the dilated figure is a length of 2. I'm counting from A to C. 1, 2. The dilated figure has a length of 2 when the original figure has a length of, now pay attention, look, I'm looking at AC. So AC goes from having a length of 2, 1, 2, the dilated figure over the original. 1, 2, 3, 4. So it went from being 2 to being 4, which means that the scale factor is 1/2. Because we simplify, we reduce 2/4 to be 1/2. And so then the sequence of transformations is that it is a reflection across the x-axis and a dilation with a scale factor of 1/2. Now you're ready to move to the next problem. Now the idea is that on this next problem, you look at it and you decide the sequence that will map ABC onto A double prime, B double prime, and C double prime. I need to correct this because this should be doubles. Pause it, see if you can figure out the transformations, and come back and check your work. The sequence of transformations that will map the original onto the final figure. This is a little tricky. So what I want you to do is get a sheet of graph paper and actually plot the original onto a sheet of graph paper, because you have to be able to see the transformation. And I don't know if you notice what happens when you move from triangle ABC to triangle A prime, B prime, C prime. Can you tell what happens without the patty paper? If you can tell what happens without the patty paper or the transparency paper, good. If you cannot see what happens, then you need to get the sheet of graph paper and patty paper and do this on paper so that you can see what happens. You can even trace the original figure and move it around to see what happened. How can you get from here to here? Let's do a process of elimination instead. So the transformations are reflection, rotation, translation, and dilation. Okay, now, first of all, here's what I want you to notice. this original triangle compared to the second triangle are the same size. How do I know they're the same size? Because I can count. 1, 2, 3. From B to C is 3. 1, 2, 3. From B to C is 3. From A to B is 1, 2, 3, 4, 5, 6. Over here from A to B is 1, 2, 3, 4, 5, 6. So the size does not change. Since the size does not change, um that first transformation is not a dilation. Now, could it be a reflection? I'm going back up. A reflection across the y-axis would put the new figure over here. A reflection across the x-axis would put it over here. It's not in the first quadrant. It's not in the third quadrant. So then we can eliminate reflection. When you translate a figure, the figure does not change the order. What am I trying to say? If I take this and I make a copy of it, or I take this and I decide to move it. So here's that figure. Sliding the figure does not change where A, B, and C are. And if I move it here, A, B, and C have changed the order. So when you slide in a figure, B, C, and A stay in the same location. So we can get rid of the idea that it is a translation. Alright, the last one is a rotation. If you take ABC and you rotate it, you will find that it is here. The question is, what type of rotation is it? That's why we need the patty paper so that we can do this on paper. I'm going to give you a copy of the problem so that you'll have it. Use the patty paper and decide how it was rotated. Once you decide how it was rotated, you'll be able to find the second transformation. I'm not going to tell you what the second transformation is, but I do want to say that when you move from A, B, C prime to A double prime, C double prime, the size changes. It went from being 3 to being 6. And that's all I'm going to tell you for right now. Get your patty paper, decide what degree it was rotated, and the scale factor. Oops, did I say that? Pause the video and complete this sequence. Press play when you want to check your answers. So this is like a big reveal party. You've looked at the sequence on paper and you think you know what the what the sequence of transformations are. Here is the final answer. Dun, 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 dun. Now you are ready for level 2.